to WBEC's TV series. You're right there. Today we'll be looking at the history of numbers, where they came from, and how we've learned to use them. Let's go to our on-the-scene reporter. Where are you?
I'm not sure, Frau Buckenstein. I think all I see around here are goats. Wait, here come some goat herders. Hello there, I'm investigating numbers. What kind of numbers do you use?
Numbers? Oh, we have very modern numbers.
We have the number 1 and the number more than 1.
That's not a lot of numbers.
It's fine for us. We don't have a lot of goats.
But how do you count the ones you have?
I have 1 goat. See how easy it is?
I have 1 and 1, so that's more than 1 goats.
No, I have 1 and 1 and 1. That's more than 1 goat.
Wait, I have 1 and 1 and 1 and 1. I have more than 1 goat.
This is silly. You all have more than 1. You just need some new numbers. You have 1 and 1, right? We call that 2 goats.
Look, I have 2 goats.
Hello. Wait, never mind.
And you have 1 and 1 and 1 goats. That's 3 goats.
1 and 1 and 1 make 3? How cool is that?
And I have 1 and 1 and 1 and 1 goats. How many do I have?
You have 4 goats. Now how many goats do you have altogether?
I know this. This is addition. 1 plus 2 plus 3 plus 4 plus 3 plus plus 4 makes more than 1.
No, it makes 10.
Why don't we go count other things?
Let's go count chickens. We have lots of chickens.
Thank you. Now we're in Sumeria, which is ancient Iraq. It's about 5,000 years ago. Here are 2 Sumerian mathematicians. I understand that you have developed a number system, gentlemen.
Yes, it's based on the number 60.
We make a little notch for the number 1 and a dot for 10.
Here comes the good part. When we get to 60, we use a big notch.
Then we add more and more notches and dots. We can make any number we want.
So your number system is really just made up of notches and dots?
We have a very advanced number system.
It's a lot better than making marks on sticks.
We're scratching lines in the dirt.
Excuse me, but we Egyptians have a much better number system than they do.
What are they doing here? This is Sumeria.
This kind of stuff happens all the time on TV.
As my friend was saying, in Egypt, we have a number system based on 10.
Not based on 60 like the Sumerian system.
After all, we have 10 fingers, not 60.
How does it work?
We have a line for 1, an arch for 10, a lotus flower for 1,000, and a frog for 100,000.
You have a frog for a number? We like frogs in Egypt.
Just because you like something doesn't mean you have to make a number out of it.
Our number system is much more advanced than yours.
10 is better than 60. Is not.
Things are getting out of hand here. Let's jump right ahead to Rome.
Okay, sorry about that. Here we are in Rome about 2,000 years ago. They've developed a number system using letters. Let's ask one of these Roman mathematicians to explain it.
Am I on TV?
Yes, you are.
Cool. So here's how our new number system works. For the number 1, we use the letter I.
Then for 5, we use a B. For 10, we use an X.
Then L for 50, C for 100, D for 500, and an M for 1,000.
This way, we can make as big as a number as we want.
Or rounding. We never use notches or frogs or anything like that for our numbers.
Okay, how would I write a big number like 3,273?
3 M's for 3,000.
2 C's for 200.
An L for 50.
2 X's for 20. For 20 more, that's 70.
And 3 I's makes it 73.
So the whole number is MMMC
number system you've ever seen or what?
How do you add or multiply numbers with all those different letters in them?
It takes a really long time.
And we make lots of mistakes.
But we're working on it.
Good, keep doing that. Meanwhile, we're moving on. We're just about ready to develop our modern number system.
Thank you. Here we are back in Iraq. We're in Baghdad about 1,200 years ago. We're here to interview Muhammad ibn Musa, better known as Al-Khwarizmi. Mr. Al-Khwarizmi, tell us about the new number systems you invented.
Oh, we didn't invent it. It took many people and many centuries to develop.
It started with the Hindus of India almost 1,000 years ago.
They invented a system with symbols for each number, 1 through 9.
Once you reach 9, you move over one place. We say the number 10, but we write it with a 1 and a 0. That way we can use the same symbols over and over again. Their value depends on what place we have in the number.
The Hindus also invented the number 0. It fills a place when you have no number to put there.
You couldn't tell the difference between 1 and 1,000,000 without zeros.
That was very exciting. But we've done something beyond that.
We've developed a system for writing numbers so anyone in the world can learn them.
We call the Arabic number system.
Didn't the Greeks also contribute to it?
Oh, of course. It takes many minds to come up with a new idea. The Greeks came up with the word arithmetic.
Arithmos is the word for number, and text means an art or a skill.
Arithmetic takes a lot of skill. Any master can tell you that.
What we and the Hindus and the Greeks and many others have done well. Now we let people use numbers to solve problems.
I'm working on a new idea. It's called algebra. It's a way of using letters to stand for things we don't know. This will help us solve more difficult problems.
That's what we call algebra.
You see, Al-Khwarizmi, they will remember what we have done.
Thank you both very much. We only have one more stop to make. Let's search for numbers.
Yes, here we are at the University of Pennsylvania in Philadelphia.
It's 1946 and we're here to see the world's first digital computer.
It's called the ENIAC. That stands for Electronic Numerical Integrator and Computer. It's so big it fills the entire huge room.
We're here with 4 computer scientists. We have been learning about number systems and what they have to do with the first computer.
Computers use a very old system called binary numbers.
It just has 2 numbers, 1 and 0. The Hindus and Al-Khwarizmi used it.
The ancient Chinese used it. They called it yin and yang.
Every number can be made up of ones and zeros.
We don't use ones, tens, and hundred places. Binary numbers have all places called ones, twos, fours, eights, sixteens, and so on.
Every number place is twice as big as the one before it.
Exactly. So our number